Hi everyone, I'm Sunitha. I'm working at Oath as an Android developer. The reason behind giving this talk today is I have been researching a bit on how to improve the app performance recently, and I thought of sharing my experience with you all. So UI in a pleasant way, but at the end of the day, what matters for an app to succeed is the user feedback and the app ratings. How does this app performance impact the user reviews and the app rating? We all would like to have a 4.5 or above rating, or even a 5. From this feedback, most of the users tend to give a 5-star rating if they think that the app is simple to use, and if the UI is looking great, and if there are no stability issues. But this is the win-win situation for us as well as the users, and this is the situation that we would like to be in, but not this one. So the reasons for getting the 1-star and the 2-star ratings is the stability issues. App getting frozen, app is slow, the crashes. So we always it would be always good to keep an eye on the app performance in order to get the positive feedback from the users. And most of the time, what happens is we try to fix all these crashes by looking at the data, which is the stack trace. That is very simple. But as far as the UI is concerned, it's a little bit tricky. How do we measure this UI performance? A certain group of people think that this UI is simple enough to use, and a certain group of people may think that the animations look good for them, but may not be for the rest of the audience. So what happens is, in order to make the UI to look smooth and pleasant to the human eye, the device refreshes the screen 60 times a second. That means it refreshes the screen every 16.62 milliseconds, which can be described as if like a frame getting drawn to the user. So it's very crucial for an app to render this particular frame in 16 milliseconds to the screen. If that doesn't happen, that particular frame may get dropped, and that could lead to jittery UI behavior, which is also called as the UI Jank. So here the vertical bars over here represent the time slices and the duration between each two different vertical bars is 16 milliseconds, and the horizontal bar represents how long a particular frame took for it to get rendered to the screen. So if we look at the first frame, it took less than 16 milliseconds, so that means it is good. What about the second frame? It also took less than 16 milliseconds, so far we are doing good. What about the third frame? It took more than 16 milliseconds. So what this means is at the time when the user is expecting to see the third frame, the user is still seeing the second frame, because that is the one that is still being displayed on their screen. So this frame get missed, and if we happen to run into these frames consistently, this could lead to UI jank. Being developers who always try to implement the code bug free and who always try to follow the best practices, why do we still run into these UI jank issues? So working in big teams is a very challenging task. Most of the time we have to coordinate with each other so that everyone is on the same page, and whatever the work that is done by one person is not impacting the work done by the other person. We run into tight schedules and tight deadlines, and not only that, the UI keeps on changing throughout the course. These are a few of the screenshots that I took from one of the apps that I worked on before. This is how the UI used to look in the early stages of the app, but this is the one of the screenshots from the later stages in the app. As we can see from these screenshots, the business logic stayed the same, whereas it's just the visual UI experience that kept on changing from one stage to the other, because we would like to provide a better user experience, right? So it's the magic always works in a fictitious world. I wish we can use some kind of magic to fix all these app performance related issues, but it never works. In the beginning, I used to time all the methods to find out which method actually caused issue and fix that. But it never worked in all the cases because I may be looking at a very minor issue rather than looking at a major issue. So after that, I started looking into the profiling tools provided by the Android framework, which could help us in identifying the UI jank and fixing those. And here is a sample app that I'm going to be going through to demonstrate how these tools can be used to identify the UI jank and fix. This is a very simple app that actually displays the images in a recycler view. And here is the on bind view holder method. And this is not doing much. I'm just assigning a bitmap to the image view. But when I scroll through the list, I do see UI janky behavior. So now I'm going to just go through the tools that can be used to find the UI jank. Dumpsys is a tool that runs on the device and captures the information at system level. This is how we can run this tool on a command line. We can pass in the package information, and right now I'm just passing GFX because I would like to just get to know the UI jank related issues, right? So that's the reason I'm trying to kind of like get only the graphics pipeline related information. I ran the Dumpsys tool with the sample app that I just showed in the earlier slide. If we look at the frames over here, on total 270 frames have been rendered to the screen, but 177 out of 270 got dropped, or those are janky frames. So that means there is definitely a serious issue with the app which needs to be taken care of. And if we look at the third 3 lines from the bottom over here, this actually provides an insight into what could be going wrong. Seems like there could be an issue with the bitmap uploads over here. But what I would recommend is automate this Dumpsys tool, and whenever there is any huge code change, or whenever you are implementing a new feature, at that time run the automation test and figure out if the new features caused any increase in the janky frames or not. Usually look at like a 10 percentile range. Like if the janky frames are more than 10%, then it's the time for you to go and fix those issues. I'm going to go through the other tools as well. This one is profile GPU rendering. This also actually captures the same information as the Dumpsys, but it displays the data in a graph format. This can be enabled through the developer options, profile GPU rendering. As you can see, it displays the graph of bars, and each bar represents how long a particular frame took to get itself to get rendered to the screen. And each bar can be displayed in multiple colors, and these colors actually represent the stage in rendering phase. For example, like input and animation. I usually don't care much about these colors because these colors differ from OS to OS. But one thing that we have to focus on, this green bar over here. I'm not sure whether that's clearly visible or not. This actually indicates a 16 milliseconds threshold. If at all, if any bar which crosses over this threshold, that means that frame actually took more than 16 milliseconds, and that could be a missed frame. And that if we run into those missed frames quite often, then that means that could lead into the UI jank issue. So what I usually try to do is I would turn on the setting and just play with the app and visually take a look at the UI areas to figure out which areas are the ones which are actually going into this UI janky issues. And here is the graph that I captured from the sample app while scrolling through the list up and down. As you can see, all these, most of the frames are crossing the 16 milliseconds threshold. That means that there is a problem with these missed frames, and this could be leading to the UI jank. And just based on the coloring over there, it seems like there is a problem with the bitmap drawing again. Now that we have identified the UI areas which could be causing the problem, we can use the systrace tool to even dig further down. Systrace actually times all the methods that are running on all the processes on a device at a system level, and this is how we can run the system systrace tool command on command line. This actually captures a lot of information, so it would be nice if we can just filter the data by the package name belonging to your app, and we can also dump all the data into the file name that is given here. And we can also mention the time, like if you want to just trace only for 10 milliseconds of the app run or 20 milliseconds of the app run. If we don't provide this, what happens is the trace will get kept, will keep on getting captured until we press enter. And as I mentioned earlier, this captures a lot of information. So if you are just looking at, if you just want to get only graphics related information, you could just you can just filter the data by the categories. And I ran the systrace tool for the sample app that I demonstrated before. And the trace gets actually stored in a HTML format, which can be opened in a Chrome browser, and we can go through that. And this is how the trace looks like, which is not delightful to the eye and which looks very overwhelming at the beginning. So now at this point, I would switch from the slides to the actual trace file so that we can go through this live. So as you can see here, this section displays the CPU related information, but usually, right now I'm actually chasing behind the UI jank, right? So what I usually do is I would just scroll down to the location where the frames related to the app that I'm working on is located. So this is the package name of my app, and here are the frames. I'm gonna zoom in a little bit. The frames which are shown in green color indicates that those frames took only less than 16 milliseconds, whereas the frames that are displayed in red color indicates that those took more than 16 milliseconds. And if this is happening consistently, that means there is a problem with the UI, and then that we need to take care of it. So let's just tap on one of these red frames which are missed frames. So when I do that, okay, so when I do that, it actually displays the alert over here, and that alert looks like this one. So based on this description over here, we can figure out what is the issue that is actually causing this this frame being missed. And we can also look at the aggregated alerts over here. Seems like there are 57 bitmap upload related alerts or issues. So that means the bitmap loading logic that I had has an issue which needs to be fixed. So let's get back to the slides. This is what we saw earlier, and these are the frames that are missed, and these are the frames that worked okay. And here is the aggregated alerts, and here is the alert that indicates what is the exact issue with the missed frame. Once we know what the problem is, we can let's just go back to the original code and take a look at this. So what am I doing here? I'm just decoding a resource and assigning that bitmap value to the image view. But what happens is this onBind view holder gets called multiple times for the same position when I try to scroll up and down. So that means I'm actually decoding the resource multiple times, which is not a good way of, which is not a good practice to implement the UI. So what we can do is instead of that, we can cache this bitmap and reuse it later. In order to fix that, I just used glide. that takes care of the caching and then reuses the bitmap later. Let's see how the trace looks like with this fix now. Now all the janky frames have been taken care of, and there are no janky frames. But I demonstrated how to use this systrace tool with a very simple app. But here are some of the alerts or some of the UI Jank issues that I ran into when I was looking into app performance issues earlier. So this one, when I looked at the description, it was not that clear, and luckily they had links for the documentation, like doc link and the video link, which actually provided a lot of information so that I could go back and fix the issue. And here is another issue that I ran into, which actually refers to the measure and the layout phases. If these take a lot of time or significant time, that could lead to the UI jank. I will cover on how to fix these issues in a later slide. And as I mentioned, systrace actually works at a system level. It captures the system level methods only. But if we want to time the app methods, we can add app level tracing to those methods or the code blocks that we would like to measure, and these traces would be handled by the systrace as well. So we can see the data in the systrace tool, and we can now fix these issues as well. I'm going to just go over a few best UI practices, but this is not the entire list. In the previous or the earlier slide, I had mentioned about measure and layout taking too much or the significant time, which causes the UI jank. So always try not to use nested layouts, because the nested layouts relate to more number of invalidations, and we could run into measure and layout phases for each and every child many times. And as far as the recycler view is concerned, let's say that if you have very small data that is getting updated, in that case, don't try to call a notify dataset changed on the adapter. Instead of that, try to use a diff util tool to figure out which are the elements that got changed, and in turn notify those particular cells that those are, the data, underlying data has been changed, so only those particular cells would get invalidated. Overdraw. Overdraw is a metric that provides information about how many times a pixel has been overdrawn on the screen. We can use this debug GPU overdraw to figure out which views are getting overdrawn. So let's say that if a pixel gets overdrawn multiple times, only the draw operation that is related to the last operation, the last phase, would be seen by the user. So we can get rid of the other rest of the draw operation calls. So I turned on the GPU overdraw setting, and brought up the calculator app. So each pixel over here actually gets displayed in different colors, and the pixel that gets displayed in true color or in no color, that means that that pixel has been drawn only once. There is no overdraw at all. Whereas if it gets displayed in blue color, that means it has been overdrawn once. Green means it has been overdrawn 2 times. Pink means it has been overdrawn thrice, and red means it has been overdrawn 4 or more times. So usually try to kind of like fix the overdraw issues which are displayed in red color. That's the kind of like a major issue. But in this case, in the calculator case, even though we had these views which are in green color, based on this app nature, these overdraws may not impact much for this app. But whereas for an other app where we are using a recycler view, and if we happen to see all these overdraws, that could impact the performance in those apps. So whatever the approach that we apply to a particular app may not be useful in the other apps, because the apps have different kind of nature, right? And always try to run the profiling tools, collect the data, analyze it, and find the major issues, not the minor issues. Always try to kind of like focus on the major issues, because minor issues, whenever you have time, you can take care of those, fix those major issues. And again, test whether the fix is working or not. So after going through all this process and making sure that the app is performant, the app could still not be performing very well on the devices out there once it gets shipped because of the fragmentation issue on the Android side. So always keep an eye on the Android Vitals dashboard, which is on the Play Store, that captures all the application related, performance related data. And last but not the least, being developers, we know what the Android framework can do. So always talk to the designers and see, like, if at all if there is any animation or any UI design would impact the app performance. Just talk to them and see, like, oh, can we make a little bit tweaks to the animation or a little bit tweaks to their UI, or can we just implement this in phases because it's going to impact the app performance and it's going to take time. So just have a little bit chat with the designers. So always be friendly with them. With that, I hope this talk is helpful to you all, and I'm going to be hanging around after the talk, and I'm going to be here the whole day tomorrow. So if you have any questions, concerns, suggestions, just come and talk to me. With that, thanks for attending the talk, and have a wonderful rest of the conference.